Welcome back, everybody. Good to see you. Well, you see you again. Hopefully, see me at least, or with the work here. This is going to be our lesson 28 homework review on perimeter, part 3. This is the questions 5 and 6, the most challenging questions here. So let's take a look. Kite, A, B, C, D. Now, kite's a quadrilateral, where it's kind of like two different sized isosceles triangle that share the same base are kind of connected. So it's kind of like isosceles triangle ABD and isosceles triangle BCD, both share the base BD. Okay, and so here, that's kite ABCD. It's drive in circle O, and so we have to use our circle rules, such that BD is 12 and AE is 4, and they're showing in this case that AE is a line segment on diameter AOC. And so what it comes down to is that AOC is perpendicular to BD, and therefore one of the theorems we know in this case is that if a diameter is perpendicular to a chord, it bisects the chord. Okay, so I'll put that down a little bit here. So just a little reminder: if a diameter of a circle is perpendicular to a chord, then it bisects the chord. I'm going to move that down, ladies and gentlemen, so don't you worry. So you can see this, and if I can find my cursor. There it goes. Here we go. Okay. Oops, no, more space there. Okay, here we go. All right, so I'm gonna close this off here. All right, so that's the idea. So we know that if BD is equal to 12, then what happens is these are congruent. BE is congruent to BD, so therefore BE is congruent to BD, and in this case BE is 6. All right, so now go, okay, AE is 4, and in this case it says here BD is 12. All right, so okay, so we have these two pieces here, and we have enough to find AB, but they're asking for CE, so they're asking for this measurement here. And so your first thought is going to be, how do I find this? No, I mean, you know, I don't really have much information about this until we realize something, that in this case angle ABC is a right angle. So the measure of angle ABC is equal to 90 degrees. So this is a right angle here. Okay, and saying, well, how do I know? Because angle ABC intercepts a semicircle that is an inscribed angle is 1/2 the measure of the intercept arc. Therefore 1/2 of 180 is 90. All right, so you go, okay, great. So how are we going to figure out, in this case, the measure of EC? Well, that leads us to one of our theorems we had about if an altitude is drawn to the hypotenuse of a right triangle. And so we're going to use in this proportion that, if you remember, projection 1 is to altitude as altitude is to projection 2. Or in this situation, we will have AE is to BE as BE is to CE. So here we're saying, okay, or in this case, we have 4 is to 6 as 6 is to x. Product of the means of the product extreme, so we have 4x equals 36. X equals 9. So we see here in this case, CE is equal to, measure CE is equal to 9. That's our first part. Okay, great. Which means that the whole measure of AC is going to be 13. Now, you might be asking, how does it help us know? Okay, well, it says here, find the diameter of a circle. So determine the perimeter of ABCD to nearest 10, show the work that leads to this. Okay, so now we gotta find the perimeter here. Well, what we're gonna do is we're gonna find AB. And because this is a kite, we should know that AB and AD are congruent, and BC, well, I'll use 2 here and 3 here, BC and DC are congruent. So he's saying, okay, well, how do we find this though? Well, we can use Pythagorean theorem. Okay, so in this case, to find AB, so AB squared plus is equal to, actually, that's the hypotenuse in this case. So hypotenuse, AB squared is equal to 4 squared plus 6 squared. Here's your right triangle. Okay, and so AB squared is equal to 16 plus 36. So AB squared is equal to 52, which means, taking the square root of both sides, AB equals the square root of 52. Again, because we're trying to find the nearest tenth, I'm not going to bother to simplify. All right, now we'll do this again. All right, so we're going to now find BC. So we know BC is hypotenuse in this case. BC squared is equal to 6 squared plus 9 squared. Here's our second triangle. We're going to put this in red, I guess. So here's our second triangle. And this is 6 and this is 9. And so we have in this case, so BC squared equals 36 plus 81. BC squared is equal to 117, actually, 117. And so BC is equal to the square root of 117. All right, so we have in this case the square root of 52 plus the square root of 117. But we want to find the perimeter of the entire quad ABCD. So that would be, in this case, this whole thing here, which the other sides are the square root of 117 and the square root of 52. So here we go. We're going to take a calculator. I'm going to actually use black in this case. So I'll do this now. So oops, square root of 52 plus square root of 52 plus square root of 117 plus square root of 117. Now I'm going to rewrite this in this case. The perimeter equals 2 square root of 52 plus 2 square root of 117. And so we're going to bring our calculator. All right, so here we go. So we're going to do the square root of the 2 times square root of 52. So 2 times the square root of 52. Because we want to find the perimeter of the kite, so all 4 sides, oops. I should have not done that. Instead, I should move to the right and then add 2 times the square root of 117. Okay, to the right, and add together as a decimal. We're going to find 36. So perimeter is, 36.05, which will be, in this case, 36.1. 36.1 will be our perimeter. All right, there you go. So that's question number 5. Now for question number 6. Determine the perimeter of the rectangle octagon that has a distance from its center to any of its vertices of 10 inches. Round your answer to nearest tenth of an inch. Well, here's what we're going to do. We know, or should know in this case, that we're going to have here, I'm going to extend this segment to O to B, and because it's a regular octagon, that all the sides are the same, and therefore what's going to happen is we're going to find out that these 2 sides are the same exact measure, isosceles triangle. Now you're probably saying to yourself, well, I wish we knew angle measures. Well, a couple of things. You could, in this case, break this down into all these triangles here by connecting O to each of the vertices. And we would find, I mean, hopefully at least, all of the triangles will be exactly the same. We can count each other. And all isosceles as well too. But their vertex angles would all be the same measurement. So that's really going to be saying in this the following, that you would have here 360 divided by 8. And so that would be, in this case, 4, 32, 40. Oh, hey, that's 45 degrees. So here, the measure of angle AOB equals 45 degrees. All right, so now what do we do? Well, I could possibly do some type, wait a minute. I want to find the measure of AB. And if I know the measure of BO is also 10, I can use the law of cosines, side, angle, side situation. And so here, for this triangle, I'm going to use the law of cosines. And then after I use law of cosines, I'm going to be able to, or what I'm going to do in this case is going to multiply by 8 because there's 8 of these. So we know we use law of cosines, x squared is equal to the first side squared, 10 squared, plus second side squared, 10 squared, minus 2 times 10 times 10 times the cosine of 45 degrees. And that's x squared, all right? So let's take our calculator. And so we have in this case, we're going to do 10 squared. So that'd be 10 squared plus 10 squared minus 2 times 10 times 10 times the cosine of 45 degrees. And again, make sure we're in degree mode. Yes, we are. We're good. All right. So in this case, hit enter, and we get 58.5786437. Now, that would be the square. So we want to take the square root of this. So it's like second square root, and you can type out the whole thing. We also hit second answer, negative symbol. And what it does is going to pick the square root of the answer you found. All right. And so now we get 7.65. All right. So we have in this case, so we know that x is approximately 7.65. So now we need 8 of this. So 7.65 times 8. Or what we're going to do is we're going to just take a calculator, our entry we have from before, and we're going to multiply that by 8. So times 8. And we get 61.229. All right. So in this case, 61.2. So approximately 61.2. All right. So we'll round off the nearest tenth of an inch, and so that'll be inches. All right. Now, just to make sure, if we use 7.65 times 8, let's see what we got though. Okay. Let's see. 7.65 times 8 is equal to 6.12. All right. So, you know, whether you round off or before, but now don't round to nearest tenth and multiply 8. Round to nearest hundredth at the very least. I mean, I like using all decimals and stuff like that because we have a calculator, but round off in this case to as far as you can. All right. So we have 61.2 inches. Okay, there you go, ladies and gentlemen. This is your perimeter of the octagon. And we had to use, well, I decided to use in this case, the law of cosines. You could have, if you want to, taken this angle here, an altitude, and then found the measure of angle BAO, and then use that to find the height. And then in this case, you would, because you're 10, you can find the height. Or more than the height to find the measure of this measurement here using trig, then double that to find AB, and then times 8. It's the same thing. Either way is fine too. All right, ladies and gentlemen, I hope this is helpful to you guys. If you found this helpful, please leave a like for this video, and I guess also please subscribe. All right, ladies and gentlemen, thanks so much. Again, hang in there. We're rounding down the stretch, and hopefully that we'll see in this case. Not every problem we think a perimeter is not as easy as it looks. We have to use all the knowledge we have from before. Anyway, thanks for watching, ladies and gentlemen. Take care and be safe.